Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 1. We're on question 36 out of 50. So this definitely is not a straightforward question. This isn't the kind of integral that you usually see. It's an integral with an integral inside of it, so we kind of just have to be careful and take our time here. So let's start with this little integral inside the big integral. It's in the denominator. Let's figure out what that is. So the integral from a to ax of dy over y. Well, we know that 1 over y, the antiderivative is log y. So that's going to be log of y from a to ax. What's that going to be? That's going to be log of ax minus log of a. Well, remember that when you subtract logs, that's the same thing as taking the log of the quotient. So that's like log of ax over a. And the a's cancel out, giving us log of x. So this whole thing inside the square here is log of x. So our integral is actually going to be the integral from e to a to the power e of dx over x log x. And now we can solve this by substitution, because if we make a substitution of u equals log x, then du equals 1 over x dx, which means that dx is equal to x du. So we can substitute here to get x du. See, this is the integral from e to a to the e of x du over x u, and the x's cancel out. And then the integral of du over u is just going to be natural log of u. And we're going to integrate that from e to a. Well, remember now, these limits of integration are for x. This is x equals e and x equals a to the e. So let's bring ourselves back into this x world. Log of u is actually the log of, what is u? Well, remember, u is equal to log of x. So log of x. And this we're going to evaluate from x equals e to x equals a to the e. So that gives us natural log of the natural log of a to the e minus natural log of e. Well, what's the natural log of e? That's just 1. And what's the natural log of 1? That's just 0. So we're left with natural log of a to the e. Now we're told that this whole integral is equal to 1, and then we're asked what is the value of a. So let's set this equal to 1. And now if we take the exponent of both sides, that will get rid of this log here. So we'll get natural log of a to the e equals e to the first power, so that's just e. And then if we raise it to, well, now remember from the properties of logarithms, this exponent can come out in front. So we get e log a equals e. So the e's cancel out, and we get log a equals 1, which means that a is equal to e, which is answer D.